Hello, let's do the New York Times Medium Sudoku for May 14th, 2024. There's a link in the description if you'd like to try the puzzle yourself in the same software I do called Sudoku Pad. And I'm going to get started right now. Okay, so we take a systematic approach to the medium solve as a teaching tool. So let's go over what you need to know here. Each of these is a cell. There's 81 of them in the grid. Each cell will end up with a digit in it, one digit, from 1 to 9. This is a row. A horizontal line of cells is a row. This is a column. A vertical line of cells is a column. And we've got our 3x3 boxes that are denoted in bold outline. There are 9 of each in the grid, and there will be 1 of each digit from 1 to 9 within each. So every row has 1 to 9. Every column has 1 to 9, and every box, every 3x3 box has 1 to 9. Exactly once each. No repetition. And they cannot be missing. Those are important concepts to understand. Okay, so next we're going to talk about bands and stacks. That's just a row of boxes or a column of boxes, respectively. Now think about a band for a second. It is made up of 3 rows and 3 boxes. So how many of each digit appears in the band? So like how many ones would we expect in the band? And the answer is 3, because there are 3 rows and each row has a single 1 in it. There are also 3 boxes and each box has a single 1 in it. That doesn't mean there's 6, there's 3, they share them, right? Like this one is both in this box and in this row. So that means that, well, if we look for digits that appear twice in a band, that third one that's missing, like we know where it is, like this one here. We know where this one is here, and we know where this one is here. The third one is restricted to only 3 cells, these 3 here, in general. And we're not talking about this specific situation, but it's restricted to 3 cells. It's going to be the 3 cells that are in the box that those aren't in, and in the row that those aren't in. Another way to think about that with these ones is this one looks into this box saying that these 3 cells can't be 1, and this one looks into this box saying these 3 cells can't be 1. And so that leaves these 3 cells. Now, of course, in this specific situation, this cell can't be 1 because there's already an 8 in there. So there are actually only 2 places in this box that can be 1. Now, we can't just place one of these ones. We don't guess in Sudoku. The Sudoku has only one solution, and so we can logically arrive at that solution. Every digit we place should be intentional and 100% logically derived, proven. If we start guessing, like, what are you going to guess? 81 different cells, and there's a very, very low chance you're going to guess right. So, but we do want to remember that we restricted 1 to just one of these 2 cells in the box. We're going to use corner marks to represent that. There are 2 kinds of markings that Sudoku Pad supports. There's the corner marks and the center marks, and we're going to use corner marks to exclusively mean that within a box, we have reduced the location for a digit. So in this case, in this box, the 1 has been reduced to just the cells that are marked with a corner mark 1. All right, so we want to find all of the duplicates in this band. I recommend a systematic approach. We need to do 3 comparisons. We compare boxes against each other. So box 1 against box 2, box 1 against box 3, and box 2 against box 3. My recommendation is to start with the box that has the fewest givens in it. So we just have to remember the fewest number of digits. We just have to remember 3 and 8. Then we look in this box and this other box for 3 and 8. And we see there's no 8, but there is a single 3. So we have these 2 3s. They look into this box, this 3 and this 3. We're always peeking down to try to find more of that digit. So we see these 2 3s here. They look up. And so there's actually only one place in this box that can be 3. This cell here is the only cell in the box that can be 3. Well, we know the box needs a 3, and there's only one cell that can be 3, and so we can place the 3 in the box. That's where it goes. Now, this software likes to celebrate putting a 3 in the corner of the grid. It just does that animation, so this is a little bit of fun. All right, so we did the 3 and the 8. Now we just have to compare these 2 boxes against each other, the 1, 4, and 6. We already took care of the 1. If we hadn't, this is when we'd do it. And then we also have these 2 6s. They look in. We look down, and we see a singular 6 down here that helps out. So there's 2 places for 6, so we'll corner mark that. Corner mark that. There we go. Okay. And that's it. Those are all the repeated digits in this band. Before we move on, I want you to look for a filled box row. The box rows are just rows within a box, right? So each box has 3 rows in it. So a completely filled one. So like this one, but if this were filled with like a 2, right? That would be a filled box row, but it's not. So we don't have any. And then also any row or box that has 4 or fewer open cells in it. So like this box has 5 open cells, so that's not one of them. We don't have any of that either. So what we're going to do is we're going to move on to the next band after having not found those. All right, so I'm going to start with this 7, 8. We do see that the 7s have repeats. These two aren't 7 because they're filled with 6 and 1. So we can place the 7 in the box. All right, we did the 7, 8. Now we're going to do the 7 and 3. 7's already taken care of, so we just need to worry about 3. There is no other 3 around here. So next thing we look for, that's all the repeats. So next thing we look for is filled box rows. This one got filled. We filled it ourselves, but that's okay. It's still filled. We know what 3 digits go in there. So what we want to do is we want to look at the 2 rows in the 2 boxes that it isn't. So it's going to be 12 cells in total. And we want to look for any digits that aren't in the box yet. And unfortunately, we don't see any. So if we did, they would be restricted in the box. You can kind of see, like, if there was, let's use the 2 example again. If there was a 2 here, 2 would be taken out of these 3 cells, but also out of these 3. And so 2 would be restricted to those 2, and that would be quite helpful, but we don't have that. So the buddy system wouldn't have found that because there wouldn't be a buddy 2, but this acts like there's a buddy 2 over here, if there was a 2 here. But we don't actually know that, so we're not going to use it, obviously. And then the last thing to look for is rows or boxes down to 4 or fewer. We do have this row that's down to 4 open cells. So what I want you to do when you encounter this is to think about what are the 4 digits that the row is missing. And that's what's going to go in these 4 cells. So we need a 2, 4, 5, and 9. And you're going to be looking around for 2s, 4s, 5s, and 9s. So I'm seeing this 2, I'm seeing this 5, I'm seeing this 9, and this 4. So let's start with this cell here, which sees the 4 and the 9. Ideally, we would have found something that saw 3 out of the 4, but 2 out of the 4 is really good anyway. So what does that mean for this cell? Well, that means this cell has only 2 possible digits. I said that the row needs 2, 4, 5, 9, and this can't be 4 or 9, so it's down to only 2 or 5. Now, we can't place a 2 or a 5 in here yet. We don't know which one it is, but we want a way to remember that. And so we're going to use center marks for that. And center marks are very much cell-centric. They focus on the cell, and they are just the comprehensive list of candidates that we think can still go in that cell. Now, obviously, only one of them is true. Only one of them will end up in that cell. But we know it's down to just 2 or 5, and that's very interesting information to know. I recommend only center marking a cell if it's down to 3 or fewer digits. Candidates is what we call those before they're placed. And so a lot of these are. This one and this one are, because we needed 2, 4, 5, 9. And this sees a 5 and this sees a 9. So this is down to 2, 4, 9. This is down to, oh, this sees 2 and 9. So this is down to 4, 5. Now this can be any of 2, 4, 5, 9. And so we are not going to mark it. Now, the next thing I want you to look for is think about 2, 4, 5, and 9 and how that resolved. Are there any digits of 2, 4, 5, 9 that got restricted to a single box? And the answer is it would have to be this box, because this can be any of 2, 4, 5, 9. If I wrote it out, it might be easier to tell that, but we're not going to leave that in. This has this box. This has every digit possible, right? So it would only be something missing from here, and 2, 4, 5, 9 are both here. So we do not have anything to do for that. And so now that is it for that row. There's no other rows or boxes down to 4 or fewer. We didn't place any new digits or anything. So we're going to move on to the next band, the final band. So we're going to start with this 4, 2 here. It's the box with the fewest givens. There's no 4 around here, but the 2 does have a buddy. That does place the 2 here. And then I'm going to look at this 5 and 9. We already took care of the 2. 5 and 9, there is another 5 and 9 in here as well. We can do them both at once because they're exactly the same. It puts the 5 and the 9 up here. All right, so if we found a third digit that went up here, we would know what all 3 digits are up here, which is very handy, but unfortunately we don't have that yet. We also, that's it for the duplicates. Notice how quickly we can look for duplicates. I sat here explaining it and it was still pretty fast. So this box row is filled. We want to look here and here for anything not in the box. 2, 5, and 9 are already in the box, so we don't find anything. Now, any rows or boxes down to 4 or fewer? Yeah, this box is down to 4. So what are the 4 digits? They are the 4, 6, 7, 8. So I'm seeing this cell sees 6. So this is 4, 7, 8. And this cell sees 4 and 7. So this is down to 6, 8. These can be any of those, unfortunately. And so we don't see any like specific restriction in this box for a specific digit. So we're not going to worry about that. Any other rows or boxes down to 4 or fewer? No, there are not. Okay, In fact, most of these digits are 2, 5, and 9. We just have this 4, 3, and 1. That could be interesting, but I don't think that they are. Okay, so we have finished with the bands. So now we're going to do the exact same thing, but with the stacks. Notice that, you know, a Sudoku puzzle, you can always just rotate it 90 degrees, and the rows become the columns, and the bands become the stacks. And so we can do the exact same thing with stacks. Just whenever I said row, just use column instead. So we're going to start with this 7, 8 here, just like you would expect. There are no 7s and 8s here, so now we just have to worry about 1, 3, 6. No 1, 3, 6s here. Okay, so we don't see anything with that. Any columns or boxes down to 4 or fewer? I am not seeing that. There is something I'm seeing here, and we will do it on the second pass if it becomes relevant. It's not something I want you to be looking for when you're starting out early on. It's something that you want to look for kind of later. I really want to mention it, but we'll get there. It has to do with this 1, 3, 6. Anyway, for anyone who wants to spot that. So we're going to move on to the next stack here. We have, let's start with this 3, 8. There are no 3, 8s down there. We have the 2, 4. Okay, we do have 2 4s. They look up. This 4 looks in. That places this 4. Okay, so now we have 2 4s in this band. So what we want to do when we place a digit is we want to follow up on anything we've already done, because now we have new information. The new information is that there is now 2 4s in this band. So we want to do what we do when there's 2 of a digit. We corner mark the 4s over here, not 1s, 4s. Okay. So we corner mark those 4s. Anything else to follow up on? Well, it could have reduced a row. It could have filled a box row. It didn't. It could have reduced a row or a box to 4 or fewer, but it didn't. So that's it. It also didn't place a digit. Like if it placed a digit, you'd want to keep following up on that, of course. So let's keep going with this stack. Are there any filled box columns? There are not. Are there any columns or boxes down to 4 or fewer? There are not. And so I believe that was all the duplicates, right? Yeah, it was. Okay, let's move on to the next stack. The final stack. We'll start with this 3 and 7. We have all 3 3s, so nothing to do with that. There is no 7 here or here. So now we do the 1, 4, and 6. We do have 2 1s. They look in here. So 1 ends up in one of these 2 cells. And then we've got the 3 and the 6. Okay. So nothing else repeating. Any filled box columns? Not really, no. Any columns or boxes down to 4 or fewer? I am seeing this column is down to 2, 5, 6, 8. This sees 6, so this is 2, 5, 8. I think this can be any of 2, 5, 6, 8. Okay. So not much more to do with that, or nothing more to do with that. This box is down to 5. This box was down to 4, but we already looked at it. It was the 4, 6, 7, 8, and it's still just 4, 6, 7, 8. Okay, so that completed our pass. And we actually got very little out of it. Some puzzles, you'll actually be done with the puzzle by the time you get to the last stack. This puzzle is different. So what we're going to do is we're going to go back and we're going to look at boxes now. We're going to look at boxes individually. And in this second pass, what I want you to look for is internal stuff to the box. So how stuff outside the box affects that box. So previously we were focused on entire bands at a time, and we were kind of focused on the band, and entire stacks at a time. We were very focused on the stack. We'd peek out a little bit, but not much. Here, we're going to focus on individual boxes, which are affected by 4 other boxes. Now, what you can do is you can look for each digit one at a time, but I find a more efficient thing to do is to pay attention to the givens in the box you're focusing on. And look at pairs of givens, especially ones that share a row or column. So for example, this 1, 3, they share a column. And so what we want to do is we want to look at because they share a column, there's going to be a row that they aren't in. We want to look for any digits in that row that aren't already in the box. And unfortunately, we don't have any matches for that. You can also look at this 1, 6 and this 3, 6. It can be helpful. So just looking at these just in general, we don't want to find anything down here that's not 1, 3, or 6. We have the 2 and the 9. So you can see how the 2 and the 9 remove 2 and 9 from 3 of these cells. So is there a 2 or a 9 over here that can help? And there's not. So we want to look over here for 2s or 9s, and we don't see any. So that's unfortunate, but that's just the case. The 2, 9 doesn't help immediately. And so that's it for that box. We're going to move on to the next box. So for example, this 4 and 3, they share a column. We want to look here. We have the 4, 3, and 6. So 6 is not in the box, but it is marked in the box, so you don't have to worry about it. You know where 6 goes. We also have these diagonals, so we can look for 2 or 7. That might be helpful. Unfortunately, it's not. And then here we can also look for 2, 7. So that's not Still no 2 7s. So over here, we can pay attention to this 1 4, not helpful. This 3 6, not helpful. You can already kind of tell that there's nothing looking into this box that's going to be helpful. We can also look vertically here because there is a hole here, right? So the 3 or the 2. So actually we found something. It's not amazing, but this 2 does look up here and none of these are 2. So actually 2 has been reduced to 2 places in this box. And that's the kind of thing we're looking for. We're looking for any opportunity to do more pencil marking or place a digit if we didn't find that, or if we can find that. So there's nothing else really looking into this box in an interesting way. We just have this 8, but it's not interesting in any way. All right, this next box, we kind of have this gap here. We have this gap here. You kind of want to be looking at that. We've got this 2 and 9 looking in, but unfortunately there's no 2 9s over here helping. This box here, we've got the 1 4 6 7. So we already kind of looked through here, right? We already looked at this filled box row. But we could look here, like for this 2 to help. But really anything that's going to help is going to be here, and there's nothing helping here. So we're going to move on. We have this 7 3. I'm seeing we have the 6 5 and 1. We already have the 1s marked, but 6 and 5 maybe are helpful. We have the 6s down to 3 places. That's not helpful. We're only going to corner mark in a box if we're down to 2 places, and in special case 3 cases if they're all in the same row. But in this case, for example, this 6, these 6s, it would put 6 in these 3, and we do not want a corner mark around a corner like that. It's just going to confuse us when we look for stuff like pointing and claiming, because we may not notice that things have been reduced, are turning a corner like that. So it's just going to cause more mistakes than be helpful. So nothing that I see there that can be helpful. All right, we're going to move on to this box here. You sometimes find things, you sometimes don't, but these are the things that will be the most helpful if you can find them. So notice this gap here, right? This row is empty. So if there's anything here that's helpful, that might be especially helpful. So this 4 looking in, it's down to 3 places, but there's no 4 helping out up here. I don't really, this is also a gap. We have the 1 and the 3 and the 7. Okay, so this is something that, yeah, we can start with the 3, I guess. But hopefully you see something with 1 3 7. If not, I'll explain it in a moment. But if we're specifically looking for 1s, 3s, or 7s over here, we do have this 3 and this 1. So let's look at the consequence. Let's start with the 1. The 1 looks down. Unfortunately, this one is lined up with this 9 5 that are already taking it out here. So 1's limited to these 3. But the 3, it looks down. This 3 looks in. And this 9 5 are 2 additional places that can't be 3. And so what's the consequence of that? Well, the consequence is that 3 is in one of these 2 cells. And this is going to do something called pointing. This is the first time we've had pointing in this puzzle, useful pointing at least. So in this box, we have reduced 3 to 2 places that we have corner marked here. And those 2 cells happen to both be in the same row. They're both in row 8. It was reduced because of the box, but we've also now reduced the row. Basically, these 2 cells cannot be 3 anymore. The entire rest of the row can't be 3, but in this case, it's these 2 cells. Now, what's the reason for that? Well, wherever this 3 ends up in this box, we know the box will have a 3 because it needs 1 of each digit. And wherever it ends up in this box, it will be in row 8. It will be in this row. It'll be here or here. Does the rest of the row care how the 3 resolves? Not really. Whether the 3 is here or the 3 is here, the rest of this row cannot be 3. So these can't be 3. And this 3 looks in here, and this 3 looks down. So we can actually place 3 in this box, placed right here. Now we want to follow up, right? We kind of already got that from the band. And so let's look at the stack first. And we do have a buddy. These 3s look in, that places this 3. Now let's follow up on that. These 2 3s, we always look for buddies first. Follow up on buddies first. It puts a 3 in one of these 2 cells. All right, so now let's backtrack. Did we fill up any box rows or box columns? We didn't fill up this box row. We did fill up this box column. So let's look here for anything that might be helpful. 3 and 4 are already placed, but 8 is not. So what's this 8 doing? It's taking 8 out of these 3 cells, and these 3 cells happen to not be 8. So where does the 8 go in the box? Well, it only goes in one of these 2 cells. We can corner mark that, and that also points. Notice how in this box, where the 8 will end up in column 4. So the rest of column 4 cannot be 8. And this 8 also looks down. So that puts an 8 in one of these 2 cells. All right. The other thing we can follow up on is if we reduced any row, column, or box to 4 or fewer. The first thing I noticed is this row went down to 4 or fewer. So let's think about what they need. We have 1, 2, 3. So we need 4, 6, 7, 8. We know this one can't be 7. So this is 4, 6, 8. Oops, I meant to center mark that. 4, 6, 8. This can't be 4 or 6. So this is only 7, 8. And I think this is still any of 4, 6, 7, 8. Okay. And now this box also was reduced to 4. So we need 2, 5, 8, 9. We already know the 8's over here. So this is 5, 8, 9. Or sorry, this is 2, 5, 9. Sorry, I misremembered. 2, 5, 8, 9. No, okay. Trying to keep 4 digits in my head is about the max I can do. I can sometimes get away with 5. That's why I recommend 4 or fewer. You can actually think about it. You can keep those digits in your head, hopefully. Every person's different, though, so do what works for you. This is just my recommendation. All right, so that was the follow-up on these 3s here. We found the duplicate 3. Now, there's something else I want you to try to notice about this 137, which is that in this box, these 3 cells cannot be 137. And we also have a 2, 5, and 9 here. The box needs 1, 3, and 7, and they can only go here. We need 137. There are only 3 cells left in the box that can contain a 1, 3, or 7. So, how many cells do we need for 1, 3, and 7? Well, we need 3 cells for that. How many cells can be 137? There are only 3 cells that can be. Well, that matches up. And so these cells can only be 137, because if they were anything else, like let's say we tried to put an 8 here, or not 8, 8's a bad example, 7 here. Nope, 7's a bad example. Let me find a good one. 4. Let's say whoa, sorry, I like opened the source of the page by right-clicking and clicking. Okay, back to this. 7 was a bad example. We said 4, yeah, okay. So there's no immediate reason to think that this cell can't be 4, right? There's no 4 in the column. It's not even red, right? There's no 4 in the row. There's no 4 in the box that we placed yet. So there's no reason to think it couldn't be 4. So 4 should be in the candidate list at least, right? But actually, no, it can't be. Because if this was 4, I can place 2 of 137. Like I could put 1, 3 here, or 7, 3, or 7, 1. But then I can't place the third one. I have excluded the third digit. In this case, I've excluded 3 from this box entirely. So if I try to put a 3 here, now I've excluded 1 from this box entirely. Okay, what if I put 1 here? I've excluded 7. There's no way to do it, right? Mathematically, there's no way to do it. So we have proven that these are only from 137. And this one's not 3. Which means that the remaining 3 digits in this box, since 137 are approximately here, then approximately here we have 468. And that is what's called a naked triple. This 468 naked triple. So let's think about that. It's kind of the opposite of what we just did. It's kind of like the other side of the coin. What do these center marks mean? These center marks mean that this cell in the final answer to our puzzle will have a 4, a 6, or an 8 in it. There's no other option. It will only be 4, 6, or 8. Same with this one, same with this one. It doesn't matter that I don't actually have a 4 filled in here. We could, if you want, I can put a 4 in there. It's not going to be 4, but that's okay, right? But all of these cells, if I were to, well, I guess let's start here. Can I repeat any digits? Well, of course not. They're in the same column and in the same box, right? 2 reasons you can't repeat digits. I'm not going to be able to put 2 4s here, right? So how many digits do I need for these 3 cells? Well, I need 3 digits to fill in these 3 cells. What are all of the possible digits among these 3 cells? And all of the possible digits among these 3 cells are 4, 6, and 8. That's the comprehensive list. If I want to fill any digit into any one of these 3 cells, 4, 6, 8, right? If this was possible to be, I don't know, I have to make something up. If this was possible to be a 1, it's going to be red. But if this was possible to be a 1, the total comprehensive list would be 1, 4, 6, 8. That would be 4 digits. But this can't actually be 1. These can only be 4, 6, 8. And so because of that, all 3 are going to get used. We don't know what order they're going to end up, but maybe we'll be 4, 6, 8 like this. Or maybe we'll be 6, 8, 4. Or maybe we'll be 8, 6, 4. Or maybe we'll be 4, 8, 6, right? We don't know how it's going to resolve, but these will be 4, 6, and 8. There's no other choice. There's not another digit that could go in them, and all 3 have to go in there. So does this column care how they resolve? Does this 4 here, right? Can I put a 4 here? Can this resolve in some way such that I can put a 4 here? Well, let's see what happens. If I put a 4 here, this can't be 4, and this can't be 4. And now we have to spread 6, 8 across 3 cells. Well, there's not enough butter for the bread. I can put 6 and 8 here, but now this won't have anything. Or I could put 6 and 8 here, but now this won't have anything. So we're not allowed to do that. This actually can't be a 4. In fact, the rest of the column can't be 4, 6, 8 in general. So first thing I'm going to do is I'm going to remove this 4 corner mark because it actually isn't true. This can't be 4 anymore. And that leaves only one place in this box that can be 4, so let's place it. Immediate follow-up here is we can place this 5 because this cell now can't be 4. And now the comprehensive list of all digits that can be in there is 5. And so that is a 5. And now that makes this a 2. And that leaves 4 and 9 for the rest of the row. But remember, this actually can't be 4 because of the 4, 6, 8 triple. So this ends up the 9 and this ends up the 4. Now this can't be 4. We place this 2, which looks up here, removes one of the corner mark 2s. Remember, we found that later on, but it was a very helpful corner mark because now we know that 2 can only be in one place in this box, so we can place it. There's not an immediate follow-up for the 2. I'm going to do the easy follow-ups first, and then we'll go back and see what the state of the grid is for the more in-depth follow-ups. So I did place this 5. These 2 5s do. Finding buddies is one of the most important things. Resolving the naked singles, always really, really nice. But then you want to go back and you want to look for buddies. So we have a buddy for the 5 up here. That places this 5. No buddies over here. Follow up in the way that makes the most sense to you. Just try to remember to do it. It's easy to forget. The blue digits can remind you. So at the very least, just go over all the blue digits again and look for buddies is a good strategy there. So like even that 3 we placed a long time ago, but I still looked. It doesn't hurt. You might find something you didn't find last time. Okay, and we've got these 2 4s now. They look down. So 4 ends up in one of these 2 cells. Did we place anything else? The 9 and the 5 we kind of took care of. All these are filled now, so we kind of want to just look for anything in these rows that might be helpful. So this 4 looking in is helpful. This 4 looks down. Puts a 4 in one of these 2 cells, and that's going to point. Oh no, sorry, we already had both of these 4s. Right, we're not gonna have to deal with pointing because this row is completely done. The 7 and the 3. The 3 we have marked. Okay, I don't think there's anything else to do there. So now how about this cell here, right? This can't be 4 actually. I don't know why I marked the 4 there. I forgot already. So we can place this 4. This is actually just whatever digit isn't known, right? This is the 2 because we don't know about the 2 in this column yet. It can only go here. So this is the 2. This is not a 2 anymore. In fact, 2 ends up down here. Okay, so now we want to think about like what is the lowest hanging fruit we can do. Okay, well we do have a buddy for the 2 that looks up here. Puts a 2 in one of these 2. Now this is going to be very similar to what we found down here, but the corner marks have actually informed of us of it, so it's a little easier to spot. Where can the 2 and 9 go in this box? Well, the corner marks are telling us they both can only go in these 2 cells. Well, we need 2 cells for the 2 and 9. We need to have the right amount of butter for our bread, or the right amount of bread for our butter in this case. If the butter is the candidates and the bread is the cells, we need just the right amount of butter to put onto the bread. In this case, we have both the 2 and the 9. That's 2 digits, and we have 2 cells that can take them, so those 2 cells do take them. So that's called a hidden pair. This was called a hidden triple, by the way. This was called a naked triple, in case you want the terms. Hidden always means we're dealing with a row, column, or box. So in this case, we looked at the box. We saw that 2 and 9 were limited. Naked means we're dealing with an individual cell or multiple individual cells. Basically, are we using the corner marks or are we using the center marks would be a way to think about it. So naked used the restrictions on individual cells that happen to share a row, column, or box. So we have this 2, 9 pair. That means this is a pair for the rest of the box. Whatever digits are missing, right? So it's the 7 and 8. This 8 says 8 can't go here, so the 8 goes here, and that makes this a 7. This 8 resolves this 5. Now I'm looking at this column, and I'm seeing it's down to 6 and 8 only. I'm just going to mark the 6, 8 now. The 5 does have a buddy, right? It puts a 5 in one of these 2. Guess what? We found another hidden pair, so we can put the 1, 5 there. There's a lot to follow up on here, so we're just going to do our best. I'm just going to... It helps to just keep following up on what you found, and you'll get back to the other stuff later. That's how I do it anyway. Because here we have this hidden 1, 5 pair. That means we still need 2 and 9 for the row in these 2 cells. And this one can't be 2 for 2 reasons. So it ends up the 9. That's 2 and 9. Okay. So looking for the lowest hanging fruit, always a good idea. I am seeing the 7. Let's clean that up. It does put a 7 on one of these two, but I don't think there's any like a follow-up from that right now. This box is down to 3 open cells. Anytime you see a row, column, or box down to 3 or fewer, especially if it's 1, you fill the digit. If it's 2, definitely fill that pair. If it's 3, I think thinking about that triple, look for things in that order if you can. But if you happen to see it and you didn't happen to notice another one, that's fine. But we're down to 1, 3, and 9 here. So I'm seeing this 9 looking in, saying that none of those are 9. So that is something we failed to follow up on, is placing this 9. Oh no, sorry, we don't need 9. I was like, what the heck? Sorry, let's try that again. We need 1, 3, and 6. Okay, yeah, that tells a different story. So these are just from 1, 3, 6, and this top one's not 3. This one's not 6. Does mean 6 is in one of these two. Oops, 6 is in one of these. Ah, shoot, let me undo. 6 is one of these two. Okay. So that wasn't immediately helpful. We are looking on the lookout for more triples, pairs, things like that, but I don't immediately see any. So this let's just start at the top here. These are down to 3. 2, 6, 7 is what's left. So this one's not 2 and it's not 6. So it can only be 7. So that's what it is. And that finishes this box. As soon as you finish a box, let's just complete it, right? This is the 8 for the box. All right, so did the 7 or the 8, did they have buddies? Yeah, so the 7 buddies up. That lets us place this 7, and now there's going to be naked single follow-ups. It's going to finish this triple, right? The 1, 3, and 7. And that finishes this triple, 3. Oh, it doesn't, actually. It leaves a 3, 6 pair. My bad. I thought it would finish it. Let's go back up here now. This is a pair now, and I don't remember what it is now. It's 2 and 6. So this 2 tells us the order. This is the 6, this is the 2. That places, so this can't be 2 anymore, so that places 2 in the box, only 1 2 corner mark left, which then places the 8 in the box, only 1 8 corner mark left. That comes down here, placing the 7, meaning this is down to 4, 6, 8. It's not an 8 either. In fact, 8 in this box, I'm noticing, can only be here. So that removes that 8, and that gives us the 6 here, which resolves this 1, 6. From here, we're just going to follow things around. That 1 isn't there, so that places the 1. This is 5 or 9, but it can't be 5, so that's 9, that's 5, that's 9. That removes this corner mark 5, 9. It does give us this hidden 5, 9 pair here. You don't need to worry about the 8 corner mark, because the 5s and the 9s are corner marked in the same 2, right? So that's a 5, 9 hidden pair, and that means this can't be 8 anymore. That places this 8. It gives us the 6, 4, and 8. That's a 6 and a 4. What are the 2 digits for this box? The 1, which goes here, and something, the 6. That 1 does resolve the 5, 9, 5, and 1. And then here we need 3. Nope, we don't need 3. We need 7 and 9. That's 9, that's 7. And then here we need 5 and 8. It's 5 and 8, and we're done. All right, this seemed like a bit of a harder medium today. You had to notice that. One thing I wanted to point out is there was another thing we could have done with these 3 digits. So, what we have here, and this can be done from the very start. I'm not going to reset the puzzle, but let's look at this 1, 3, 6. So this is something you can look out for, and this is something that's very nice to spot, especially in the hard solves. It doesn't show up as often in the mediums, but when it does, anywhere, it's useful. So let's think about this column. Notice how the 1, 3, and 6 are all avoiding this column. And so how many cells even if we just focus on this box, how many cells remain for the 1, 3, and 6? And the answer is only these 6 remain for 1, 3, and 6, right? We're going to have, we got plenty of room, right? Just not even looking at it, we got plenty of room. We got 6 cells for 1, 3, 6, but it is less than 9, right? That's, and then we can look down, we can see, okay, are there actually any known 1, 3, 6s? And we only were given this 2 and 9. And the 2 and 9 are not 1, 3, 6. So actually, now we're down to only 4 places for 1, 3, 6. Now look at this cell here that I'm going to mark blue. Actually, let's use yellow. This yellow cell, look, it sees a 1, 3, and 6. So if you see 1, 3, 6 in a box like this, it doesn't hurt. And I call this more advanced, and I tried not to use it. We ended up actually using the 1, 3, 7, which does a very similar thing. But this 1, 3, 6, it's not here, here, or here. So there are actually only 3 cells left for 1, 3, 6, and so those cells must be 1, 3, 6. I'll put them in red. And so from the very start, we could have penciled 136 into these. And you can see they ended up 136. It would have been correct. And of course it would have been correct. It's logically true. So that's a hidden triple in the column. It just so happened that we had this 137. I found that that was a bit easier to talk about because we were already looking at how this box was internally affected. If we got through all the internals and we didn't get there, the third pass would be looking for geometry like this. Like you focus on the 136, you focus on the column they aren't in. You look at this 38, you focus on the row and the column they aren't in, right? Look at this 147, you focus on the row and the column they aren't in, right? And you're looking for where they go, right? 146, 146, the row and the column are going to have it outside of that box, right? You're going to look at this 6-1 and you're going to go, okay, where do 6 and 1 go in this column? Where do 6 and 1 go in these two rows? And you're just going to keep looking at that. So that's an external scan, right? You're looking at how the givens in a box affect the boxes around it. And that's what I recommend doing that last because it is a bit more advanced. But in my hard solves, I do fluidly look for all of that when I scan a band and stack. I am looking for stuff like that. Just in the mediums, I've decided that that is kind of the third pass to look for. All right, so hopefully that was helpful, especially that little bit at the end. Little preview of the stuff you might have to find when you do the hard solves. And of course, if you enjoyed this, why not leave a like, subscribe, and a kind comment below.